2.8c is all about proofs using linear pairs, angle bisectors, and right angles. We're going to start with a 5-minute check that reviews what we did yesterday on angle addition proofs. So remember that when you're given a proof, you want to go through, if there are no wordy statements, there's a good chance it's an angle addition proof. So you want to start by labeling your parts and your holes. Angle 1 and angle 3 are your given, so we mark those being congruent, and those are each an individual angle, so that would be part. Angle ABE is made up of multiple angles and DBC, so that would be whole. So you have to ask yourself, if I started a part and I need to get to a whole, would I add to get to the whole or subtract to get to the whole? And this should be an add. And the thing is that we're actually missing a second part here, and you're going to add those two parts together to get the whole. And if you look at angle ABE, you can see ABE, if I were to mark it, and DBC overlap at angle 2. So that's actually going to be the second part that we add in. But let's go ahead and put our first part in. Angle 1 is congruent to angle 3. That's our given. Remember, we have to convert it over to equality before we can do anything with it. So the measure of angle 1 equals the measure of angle 3, and that, when we convert from congruence to equality, is always definition of congruent angles. Now, we only have one part, and if we're going to add, we need a second part. So the second part is this angle 2, where the two large angles overlap. So we're going to say the measure of angle 2 equals the measure of angle 2, and anytime it looks exactly the same on both sides, then that's going to be reflexive, of course, like a mirror, exactly the same. Now we have our two parts, this set of parts and this set of parts. So we add this reflexive part in here, and we can now add like our hint tells us to do. So when we add down here, if we add the left sides, we get the measure of angle 1 plus the measure of angle 2 equals measure of angle 2 plus the measure of angle 3. All we're doing is adding down the left side and adding down the right side. So that isn't angle addition, it's just plain old addition. Now we've stretched or added these two angles together, and if we look at the picture, 1 plus 2 does make up angle ABE, which is where we're trying to get to. And 2 plus 3 does add up to angle DBC, which is where we're trying to get to. So we want to squish this down into a single angle. Squish these down into a single angle. Now before you can do that, you have to use an angle addition step that tells you what they will squish down into. So whole equals part plus part, whole equals part plus part, and our two holes are these two holes we labeled right here. So they go here and here, measure of angle ABE, and the measure of angle DBC. ABE is made up of angle 1 and 2. DBC is made up of angle 2 and 3. So now, if we look at 1 and 2, since 1 and 2 is equal to ABE, instead of writing this double angle, we're going to condense it down into a single angle, which is the measure of angle ABE. And instead of writing angle 2 plus 3, which is equal to this guy, we're going to take DBC and put it in the place of that guy, or condense it down into the measure of angle DBC. Now anytime you expand, oops, this is 6, I'm sorry. Anytime you expand or contract, and in this case we're contracting into a single angle, that is always going to be substitution. And then converting from equality to congruence will be your definition of congruent angles. Okay? So If you need more on that, you can look back at the previous notes 2.8b. But let's go ahead and move on to the proofs that we really want to talk about today, which are proofs that have some wordy statements in them. So if you look at the back of your Cornell sheet, it says, "We the people eat pizza." We the people eat pizza. And this kind of gives you a little guide how you want to work through these proofs. Now the first thing you want to do is undo any wordy statements. So if you look at number 2, we have a wordy statement here, which we want to undo. So ray Vx bisects angle WVY. We're going to go ahead and put the other one, ray Vy bisects angle XVZ. Now if we look at the picture, if Vx, this guy, bisects this angle, then that means that's the knife that's cutting this angle in half, which means these two angles are congruent. So when we undo this wordy statement, that's what I mean by that. We're going to change it to say angle WVX is congruent to angle XVY. This angle is congruent to this angle. And the reason we can undo that wordy statements are always going to be definitions. They're always definitions. So this one is definition of, and you just look for the word, and the word is of course bisect. So definition of angle bisector. Okay. Now we have a second wordy statement which we can undo in the same step. Vy, this time is going to be the knife, cuts this angle. So if Vy is cutting this bottom two angles in half, then that means these two angles will be congruent. And since this one's already got a single marking, we just copy that single marking down here. So we want to state that XVY is congruent to YVZ. Angle XVY is congruent to angle YVZ for the same reason, definition of angle bisector. Now what we're trying to prove is that WVX, this one, is congruent to YVZ, this one. And you can see we already have them marked congruent. But we need to state that in our proof and figure out why that is true. And that's actually going to be our third step. Angle WVX is congruent to angle YVZ. And here's where it's coming from. So once we undo our wordy statements, we don't look at those guys anymore. So the only thing we have left are these two statements here. We know WVX is congruent to XVY, and XVY is repeated again here, is congruent to YVZ. So the common link is XVY. We throw that link out and we set the leftover guys equal, or in this case congruent to each other. So anytime we throw out a common link and set the leftovers equal to each other, it's either transitive or substitution. And since this one is congruence, then this one would have to be transitive. So remember, it's that transitive is if A is congruent to B and B is congruent to C, then A is congruent to C because you reach across the common link. So we use our wordy statements, and then we didn't even get to these other things. So I will, well, we did get to the P, which is plugging in. And we got to this one, equal to the same thing. Okay, but we use transitive to link those two together. We'll work more on this as we move into the next proof. All right, so this one says angle 1 is supplementary to angle 3, and we're trying to prove that angle 2 is supplementary to angle 3. So in this case, we have wordy statements at the beginning and the end. So we always take the time to do that. Angle 1 is supplementary to angle 3 because those are the easiest things to do in the proof. And then we don't know how many steps this is, so we'll just put it all the way down at the bottom. Angle 2 is supplementary to angle 3. Okay, so we think about what supplementary means to us, and we want to undo that wordy statement. So supplementary means that they add up to 180. So to undo that wordy statement, we can just say the measure of angle 1 plus the measure of angle 3 equals 180. And again, remember, wordy statements are always definitions. So this one would be definition of, and look at the word, supplementary. You can just write sup, definition of sup. All right, now we don't know how many steps this is, but we can undo this one exactly the way we undid this wordy statement. So if we're trying to prove that angle 2 is supplementary to angle 3, we can first find a way to prove that the measure of angle 2 plus the measure of angle 3 equals 180. So those linkings will always be together. If it says they're supplementary, they add up to 180. If we're trying to prove they're supplementary, then we can work backwards and say that they add up to 180. Now the reason always goes at the end of the pairing. So when we link these two together, the reason goes at the end, the second step. Okay? So here when we link these two together, the reason goes at the end, the second step here. Definition of supplementary, it's the same word. Here we're just going forward with it, here we're going backward with it, but it's still the same definition. Okay? So you always undo your wordy statements so you can kind of make this gap a little smaller. And then you can start talking about the tough stuff. When you get stuck, you go to the wordy, you undo your wordy statements and you're stuck, then the next thing you want to do is go to the picture. And so there are 3 things that you can find from the picture. And if you look at the back of your Cornell sheet, these are all on here. You could find angle addition, but we don't have any angle addition. You could find linear pair postulate, but there's no linear pair postulate here. Or you can find vertical angles. And where do we have some vertical angles? We know that angle 1 and angle 2 are vertical angles, so we can mark those congruent. And you have to mark in the previous problem. In this case, you probably should mark this, but supplementary, there's no way to mark that. So this would be the only marking that would be in your diagram. So is that going to help us to know that 1 and 2 are vertical angles and that vertical angles are congruent? What you want to look at is where we're coming from. We're at 1 plus 3 equals 180. We're trying to get to 2 plus 3 equals 180. So you want to think about what the difference is between these two statements. The only difference is, instead of angle 1 here, we have angle 2 in its place. And it is because they are vertical that we are able to swap those out because they are equal to each other. So that will help us. So we'll go ahead and add that. Angle 1 is congruent to angle 2, and that comes from the picture. Vertical angles are congruent. Now, we can't swap this guy into this mathematical statement until we convert it to equality. So that's our next step. We bring it as a congruence because it says vertical angles are congruent. It must say congruent first. And then we convert it. Measure of angle 1 equals the measure of angle 2 using our very favorite definition of congruent angles. And that's step 4. And now, since 1 and 2 are equal, instead of writing 1 here, that means I can put 2 in its place, and I get this statement, 2 plus 3 equals 180. So when I put 2 in its place, just like when I'm absent and there's a sub here for me, this is substitution. Okay, when you put anything in place of something else, that's always going to be substitution. So that's step 5, and we already then know we're going to convert it back to supplementary at the end, which gives us step 6. So oftentimes it's helpful to work from the beginning and to work from the end. And if that means there's a little gap in here because you didn't know how much space you need, that's totally fine. Okay? It's good to do everything you can, all those wordy statements. Then we went to the picture, and then we didn't do equal to the same thing, but we did a plug-in step. Plugging in something for something else. So that was our next step there. Okay? So moving on. Number 4 says angle ABC is a right angle. That's another wordy statement. Yay, we like wordy statements. They're easy to undo. ABC is a right angle. And we should mark that with a box in our proof. And that's given. And we also know angle 1 is complementary to angle 2. We don't actually know that. That's what we're trying to prove. But those are both wordy statements, which means we can undo both of those. So what does it mean if ABC is a right angle? What does that box mean? It means that the measure of angle ABC equals 90 degrees. And remember, when you're doing wordy statements, those are almost always or always going to be a definition. So that's definition of, and what word do you see? Right angle, definition of a right angle. Okay? Now, we can undo this guy too. Complementary. What does complementary mean? Complementary means that they add up to 90. So we say the measure of angle 1 plus the measure of angle 2 equals 90. Okay? And what's that definition going to be? Remember, it goes at the end of the pairing, so it goes down here. Definition of, and what word is it that we see? Complementary. Def of comp is fine. Okay? Now, here we are. We undid the wordy statements and we're all done. We did them here, we did them here. The next thing we want to do is go to the picture. Now there are three things, remember, you can find from the picture. Angle addition, linear pair postulate, or vertical angles. There are no vertical angles because remember, vertical angles are angles across from each other. Oops, like that. There's no linear pairs because remember, this is a linear pair. But we do have an angle addition because we have a larger angle that's made up of two smaller angles. So that's actually what we're going to do next. Angle ABC, or the measure of angle ABC, equals the measure of angle 1 plus the measure of angle 2. And that came from the picture, and that is, of course, angle addition. Remember, anytime you do whole equals part plus part, that's always going to be angle addition. Okay? So we undid our wordy statements at the beginning and at the end. We went to the picture and we found an angle addition. Now E, we the people eat. We want to find two things equal to the same thing. Again, you should have your Cornell sheet out and be looking at the back of the Cornell sheet at the bottom. It has all of these written out. That's what you should use when you're working through the proof. But we have two things that are equal to the same thing because this line is equal to angle ABC, and then this line is also equal to angle ABC. So let's put a box around those two guys. So both lines are equal to the same thing. So we throw out that link and we set the leftovers equal to each other. And look, that's what we get down here. So we're actually almost done with this proof because this is going to be line 4. So when you take the two things that are equal to each other out and you leave these two guys left over to each other, that will always be substitution because basically what you're doing is instead of putting ABC in there, since 1 plus 2 is equal to ABC, you're putting that 1 plus 2 in place of ABC. And that's how you get this statement here. So that's your substitution. And then when you convert it back to complementary, that is your definition of complementary. So it takes 5 steps altogether. Again, there's a gap in there. That's totally fine. It's not a big deal. Work from the front, work from the back, connect it in the middle. All right. Number 5 is actually not totally finished because we need to fill this in, but you should know what should angle 2, angle 3, and angle 4 add up to. If they are the angles in a triangle, they should add up to 180 degrees. So go ahead and fill that in. That's our given. So the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180. Now the difference between this proof and the other ones is that there are no wordy statements in the given and there are no wordy statements in the proof. So that kind of leaves us with not as many steps to do, but it might mean that we don't have as many easy steps to do either because we don't have any wordy statements to undo. So wordy statements, none. So we can't do that step. Go to the picture. Okay, so remember our choices are vertical angles. I don't see any vertical angles. We've got angle addition where we have two angles that add up to another angle. Don't have any of those. Well, we do have two angles that add up to something, but it's not going to be specifically another angle. It's going to be two angles that form a line. So we've got a linear pair going on right here. So we can say the measure of angle 1 plus the measure of angle 2 equals 180, and that is linear pair postulate. Postulate. Okay, linear pair postulate says that these two angles have to add up to 180 because it's a straight line. Okay, that's the only thing we can get from the picture, so we skipped the wordy statements because there aren't any. We went to the picture. Now, equal to the same thing. Do we have two statements? Remember, this is the end, so we don't pay any attention. But we notice that in both of these, we have two statements that are both equal to the same thing, which is 180. So let's put a box around 180. So we throw out the thing that is alike, and we set these two things equal to each other. Now, usually the order doesn't matter, but if you look in the proof, the angle 1 is on the left side of the equal sign. So I'm going to go ahead and bring this guy down first. Measure of angle 1 plus the measure of angle 2 equals, and then this guy second. Measure of angle 2 plus measure of angle 3 plus measure of angle 4. So we threw out the common link and set these two equal to each other, and because it's equality, that makes this step number 3, substitution instead of transitive. Okay. If they were in congruence, then it might be transitive. So now we look at the left side, or this line versus this line, and try to figure out how they are different. Or what do both sides of this equation have in common? They both have a 2, measure of angle 2. And notice down here in the proof that 2 is gone. So what we need to do is take that 2 away. But before we're allowed to take it away, we have to state the obvious. The measure of angle 2 equals the measure of angle 2, which is, of course, a reflexive step. Okay? It's exactly the same on both sides, like a mirror image. And now that we know angle 2 is equal to angle 2, then we can subtract that away from both sides, and we're left with angle 1, and then 3 and 4 on the right side. So that's our final step, which would be subtraction. Subtraction. Okay? So no wordy statements, but we did go to the picture, and then we found two things that were equal to the same thing and set them equal to each other, and then you kind of find your way through the rest of that. Okay. The last one. There we go, sorry. Says ray EB. There we go. Ray EB is the bisector of angle AEC. So here's AEC. Be better if you had a marker for this, but here's AEC, and EB is the bisector. And if EB is the bisector, that means angle 1 must be equal to angle 2. So that's going to be our first thing, but let's get our wordy statements in here. Ray EB, we'll just say bisects angle AEC. And then at the proof, we'll say ray EC bisects angle BED. Okay, so there's our given. We're going to undo both wordy statements. We'll do that first. There is a second given, but we're actually going to wait, and no, we'll go ahead and put it in here. Angle 1 is congruent to angle 3. We got it all in there. Okay, so let's undo this wordy statement just like we showed you here. If EB is cutting AEC, then these two angles must be equal. So we say the measure of angle 1 equals the measure of angle 2. And remember, anytime you're doing wordy statements, that's a definition. Definition of, and it's a bisector of an angle, so definition of an angle, bisector. Okay. We are also going to undo this wordy statement at the end the exact same way. So if EC, this guy, bisects this angle, if EC is the knife that cuts this angle in half, then angle 2 and angle 3 would be congruent. But remember, this is the proof, so it should not be marked in the diagram. But we can say that the measure of angle 2 is equal to the measure of angle 3. And again, remember, when you pair these together, at the end of the pairing is where you give the definition of angle bisector. Okay, so we undid our wordy statement at the beginning, we undid our wordy statement at the end, and here's where we're at. And actually, we're going to make one small change. Instead of 2 equals 3, for this to work out better, we're going to say 3 equals 2. Okay, so now we can look here. Here's where we're at. Measure of angle 1 equals the measure of angle 2. Measure of angle 3 equals the measure of angle 2 is where we're trying to get to. So you can see the only difference is that instead of angle 1 here, we're putting angle 3 in its place. And why can we interchange angle 1 and 3? Because they are congruent. Okay, now there's another way that you can do this proof and leave everything in congruence and use a transitive step, but since we are used to switching over to equality, this is good practice for us anyway. So now if angle 1 is congruent to angle 3, we can't use this in here or plug it in here until we convert it to an equality. So step 3 would be measure of angle 1 equals the measure of angle 3, and anytime you convert from congruence to equality, that'd be definition of congruent angles. So now this step allows us to, instead of put angle 1 in here, we can put angle 3 in its place because it is equal to angle 1. The other way you can think about it is that angle 1 and angle 1 are the common link. That's the other way you can think of it. And you throw out the common link and you set these two guys equal to each other. Okay? So whatever makes more sense to you, but that means line 4 would be a substitution step, and line 5 would be your definition of angle bisector. Now notice I always put the reason straight across from the statement. So you don't want all your statements piling up real tight on the left side and your reasons spacing out, or vice versa, these all spaced out and then your reasons all scrunched up at the top. You want to put your statements and your reasons directly across from each other so it makes complete sense. So remember, if any of this was confusing, you can always stop, rewind, and go back.